Now I can't get microphone to work nicely. Okay, there we go. All right, everybody, welcome. Sorry about that. So my name is, I have to do my disclaimer first. I stole my company's slideshow template. I did not steal their material. If I say something crazy, sue Matt Domko, not my company. Okay, cool. So my name is Matt Domko. I used to be a professional PowerPoint slide developer and presenter. That's not true, obviously. But I was in the Army for about 10 years. Loved what I did, jumped out of airplanes for the first 9, did enterprise admin kind of stuff. And then the last 2, I moved down to Fort Gordon. It was, in the cyber protection brigade that they have down there. It was really cool because you got to get exposed to lots of different networks and the way that you do things in your organization might be completely different from another organization. So being on the team that I was on, I got to see many different organizations and many different attempts at security. It was really cool. I teach blue teamy stuff for my company. I hang out on Slack a lot and Twitter. So if you have any questions about the stuff that I talk about, that's where I pretty much live. So at #cyber. Oh, this is a different version of my slides, but that's okay. So why am I here? Whenever I was in the Army, one of the things that we had to do all the time, and it took the longest amount of time, was sit down and make a list of every single port and protocol that a system used, right? Has anybody ever done like a PPSM document before? It's so much fun, right? It's like, woo, I love doing it. No, I hate it. And so I would spend like hours in Excel and write crazy formulas, and still it was not fun at all. So I kind of sat down and I was like, how can I do this better? I wrote a tool to do it, and I was like, this is going to make my life super, super easy, right? As far as that goes. So I figured out how can I make this list, and I made the list. But then I got to thinking, I was like, well, can I use this to detect malicious activity? Is that something that I can do? And so the problem, right? Identifying malicious activity on the network. So we can do it using signatures, right? Everybody's heard of Snort or Suricata, right? It's a thing. So we have signatures. This is what they look like. And that's what they look like. And that's what they look like. That's what they look like. All in all, with just a default install of Security Onion, you end up with about 21,000 rules. Just by default. That's not even pulling updates. Just out of the box, 21,000 signatures. So this kind of points at itself, right? The problem is with signature-based detection, you can't create a signature for everything. If you don't know that someone is throwing MS-1834 right now, because it's the year 2017, you can't have a signature for it. So it doesn't protect you as well as we would like it, as well as we would like it to do. So what do we do? My idea, after I came up with that little tool to write my PPSMs, I was like, I got this. Here's what I can do to do anomaly-based alerts for super cheap, because we're the government, so we're super poor, right? That's the way that is. So this was the initial idea. Build a network baseline, write some rules in Snort that'll alert when something is not in my baseline, but happens. Didn't really know how exactly to do it, but that's what I was going to do. So I wrote it down. I was like, okay, I'm going to do this, and after I finish, I'm going to put in for a talk, and it's going to be great. So the problem was, I said I'm going to do it this way with Snort, and I ended up with about 800 lines of Snort rules saying, if not this, if not this, if not, and life was super hard. So I kind of threw that in the trash. And then I thought, well, how else do we detect malicious things? What's a similar problem that we have to take a look at? Malicious binaries, right? Finding malware on systems. It's been a thing for a very, very long time now, right? So initially, how did McAfee 1.0 detect back orifice? Well, first of all, it probably didn't, right? But but it looked for signatures, and it was looking for bad hashes, ego strings, something to fingerprint that file. And it would find it and be like, hey, this is bad. You don't want this. I know you downloaded it from your AOL Instant Messenger, but you don't want to run this program. The problem with signature detection, specifically for binaries, is how many tools do we have right now that can take a piece of malware and obfuscate it? Right? So we've got Veil Evasion, we've got Hyperion, MSF Venom even for a little while, right? Well, still sometimes it's pretty cool. On those days when you see MSF Venom work in 2017, it makes your heart get big. But there's lots of tools that we can use to evade PSPs. So yeah, signature-based detection. It's not useless, it helps, but it's not going to catch all the things. So what happened after that with PSPs? What was the next cool technique after we did signature-based detection? Okay, so one thing about me, I'm a teacher. You guys, it's a little bit bigger than I'm used to, but I'm going to ask questions, and you can holler out an answer. It's totally okay. Nobody's going to like strong arm you out of here. Does that sound like a plan? No. See, somebody at least. Okay, perfect. All right, so after signatures, right? So McAfee 1.0 had just straight signatures looking for this file hash or this string. McAfee 1.5, McAfee 2.0 maybe. I don't know. What did we bring into the mix after we realized signatures don't work? Heuristics, right, exactly. It's on the slide. Awesome, see? So heuristics, the great thing about heuristics was I don't have to catch the exact file, I just trace its pattern. So if someone remotely maps my C drive, copies a binary to it, schedules an @ job to instantly run it, like, yeah, okay, that's probably bad. That's not a thing that people do on a regular basis, right? The heuristics of that action, they're bad. So we did that, right? And now most of your antivirus suites have some sort of heuristic detection method. Really, really beneficial. Does it catch everything? Yeah, so it still doesn't catch everything. What else can we do? Whitelisting, right? Oh my goodness. I was so super excited about AppLocker and the things that you can do until I saw Chris Trunzer talk about Device Guard with Windows 10 the other day, and I was like, Device Guard is the coolest thing in the world. I mean, application whitelisting is still pretty cool, and Device Guard is just a more mature version of it. But exactly that, we can do application whitelisting. So I create a policy, and I say, all right, computer, you're only allowed to run software that I say you can. And if anything else tries to run, don't do it. Right? That's, especially in an enterprise organization, that's a thing that I can do. Right? So, let me go ahead and say only these hashes are allowed to run. Only things cited by Microsoft are allowed to run. Only things in this directory. I probably wouldn't go with that one. That doesn't sound like a good idea. But you can do it, right? If you're just trying to get it implemented. Okay, so what's Matt Domko's basic way to apply application whitelisting? This is super, super easy when you talk about it. Super, super easy when you do it. Start with an empty whitelist. Create a policy that says don't allow anything to run, but if it does, log it. So now you have a huge list of logs that say, hey, this piece of software ran on your system. So what do you know now? All the software that's running on your systems, right? So now you take that list. Yeah, you got to go through it, make sure that metservice.dll isn't being fingerprinted. But other than that, once you go through it, now you have a list of every application that's running in your enterprise. And all you had to do was create a policy that said, hey, allow this, log everything else. Done. Now you have a complete software inventory. Go you. So once you have that list and you've gone through with a fine-tooth comb and picked everything out that you want to run, you just update the policy. Now, if something that's not on your whitelist tries to run, it gets blocked. How easy is it going to be to upload a backdoor if the only thing that's allowed to run on that system is executables signed by Microsoft or executables that you've explicitly authorized? Pretty hard, right? Kind of hard to get an implant installed if you're not allowed to execute the implant. So that's the way that I'm solving it as far as applications go. And I thought maybe I do this with networking. So I'll start with an empty whitelist. I'll create a policy that logs everything that's not in my whitelist. So it's going to log everything right now. A little bit intensive, but it'll be all right. Take those logs, combine them, parse through them. Everything that is actually authorized will go in my whitelist. Everything that's not, well, it doesn't need to be happening anyway, right? Let me go ahead and create some rules that stop that. Once I have my new whitelist generated, I'm good. I just sit back, relax, review my logs every once in a while. Maybe I need to update some ports because somebody turned on a new service. So that being said, how can I do all these things? I'm a major Bro fanboy. Yeah. So how do I get data from my whitelist? I can do that with Bro. How do I have a policy that creates that logging that I want? I can do that with Bro. Logs from the new traffic that doesn't fit my whitelist? Bro. The only thing that I can't do in Bro is review new logs. Has everybody heard of Bro? Anybody not heard of Bro before? 1, 2, okay, cool. So I'll talk about it. So in 30 seconds, right? And the warning on this is my name is not Seth Hall, it's Matt Domko. So this is my version of what Bro is. It's an IDS tool suite, right? It's more like a network monitoring framework. But basically, if I have full PCAP over on the left that takes up 1 gig per second because my link is completely saturated, and I have just my net flow, right, that my Cisco devices are providing to me, which takes up maybe 1 gig in a year, Bro gives me that in between. It gives me packet string. So anything that's in a packet that can be printed out as ASCII text, we can pull that out. So just like in NetFlow, where I get my source and destination IP and ports, I can pull those out. But I can also pull out DNS requests. I can pull out HTTP GET requests. I can pull out files as they get transferred across the network. There's a script built into Bro where I can automatically extract binaries as they're being transferred across the wire. So later on, whenever I'm doing an incident response, I don't have to go in and manually pull the file out of PCAP. It already got pulled, and now it's sitting on my server. And I can analyze it the same way that I would anything else. So I love that. The plugins and scripts that come with it, it's a scripting language, so you can tell it to do whatever you want. It's amazing. And then I think I've already hit on it, the fact that logs are small. So instead of pulling a gig per second for full PCAP, I'll spend maybe a meg for a day. Not that big, right? Depending on the size of your pipe, but you're not going to be anywhere near the data storage requirements with Bro as you would be with full PCAP. And so I love it for that. It's my in-between. If I can only keep PCAP for a week, I want Bro for a year, NetFlow for 2, just so that I can see in detail what's going on. Makes life easier. Oh, by the way, this super awesome tool is built in Security Onion, so I have it turnkey. I can just spin up the VM and it's good. So as far as my Bro logs, before we take a look at what those logs look like, a couple of fields that are useful. The UID, so the connection ID. So Bro tracks each connection and it gives it a unique number. If we want to do IP source, originating host. If we want to do source port, originating port. Same thing for destination, response host, response port. Our logs, super easy to parse if you're a computer. I don't know about anybody else, but I don't want to stare at that and be like, so 157 talked to 60. No, that's way too much work. I'm not going to do it. I'm going to use something like ELSA or Splunk or Elasticstack. As far as Bro configuration directories, these are the ones that I use right now because they feed into my tool. So just a couple of reference points. If later on you're like, hey, I want to try out Bropy, you can take a look back. Basically, you need to know where the scripts are going to go. You need to know where your logs are going to be, and you need to know where the configuration file for Bro, where it loads up the scripts. This is the default for Security Onion. If you compile from source and install it yourself, it'll be wherever you told it to be. So 2013, 2014, I don't remember which one. 2015, okay. I was at Security Onion Con, and Seth Hall, one of the developers of the Bro project, he's my hero. And he's up front, and I'm waiting. I'm eager for him to lay down some Bro knowledge. And he steps up there and he says, the best way to learn to write Bro scripts is to write Bro scripts. And I was like, yeah, but I don't know how, so that's why I'm at your talk. Could you please tell me about it? And I was freaking out because I thought he wasn't going to actually talk about it. So he said that, and I was like, that's kind of a jerk move. But then I started working on my own bro scripts, and I was like, okay, so he was exactly right. This is just like any other language. You want to know the best way to learn Python? Start writing Python. Make yourself write Python. You want to learn C? Same thing. Bro, exactly same way. So I figured, in interest of learning, let's write a simple bro script and work through it. All of the pieces to this script are actually used in one of the scripts that comes with Bropy, and it's what does the heavy lifting, the logging, and the alerting. So our bro scripts, we can use variables just like in any other language, right? If this were Python, so set port, this is a list of ports. I give it curly braces, the port number, and then the protocol. Too easy. Bro scripts are actually event-driven. So my script, a packet can come in, cause an action, cause an event, and all the scripts that are listening for that event can take action at the same time. So that's pretty cool. The only downside to that is if you're writing scripts, you have to know what the different events do and that they exist, right? But it's really cool. My script can cause an event, or a packet can cause an event, or another script can cause an event, and everything kind of gets to execute at the same time. It's really nice. So event bro init, when bro first starts up, what do I want it to do? Well, I want it to print a string, and then I want it to do format string. So I took my variable, and using the pipes, I don't have a, on the right-hand side, you can see pipes my ports. So that's actually going to tell me how many items are in my ports. After that, I said, okay, the next event that I want to track is new connection. So every time a new connection is detected, I want bro to do something for me. What do I want it to do? I want to check the destination port and see if it's in that list we created earlier. It's pretty simple, right? So if the destination port is in my list, I want to print an alert to the screen or do something. Okay. I feel like I'm... Nope. Okay. That's those three things: an if statement, the ability to call a file or to call a list. That's what I'm doing as far as my bro scripting goes. This bro script that I'm using is baseline report.bro. It's also on GitHub with Bropy. But basically, it pulls in a table and it checks every single new connection. Is this in the database? If it is this source allowed to talk to that destination? So yeah, my file server, people within the organization should be allowed to talk to the file server, right? People on the internet, even if I have the worst admin in the world, should not be allowed to talk to my file server, right? Like, that's not a thing. So that's what we're doing. We're checking source and destination to see if they're authorized. If they are, cool, we're good. Next packet. If they're not, let's go ahead and do some logging. As far as installing it goes, super simple. You download the script, edit a line that tells it what subnet you want to protect, because you obviously don't want to check every single packet that goes across the network, just the hosts that you want to baseline, right? And you want to manage for that. So you do that, you copy it to wherever your scripts go. You edit local.bro to call baseline report and restart bro. That's it. Except we don't have a baseline. So what you'll have to do is go through... That's not going to work, is it? So what you'll have to do is hop into ELSA. Maybe? I'm just having a terrible day with computers. Either way, you'll hop into ELSA and you'll just make a list of every single port and protocol that you use based on searches in Security Onion. Why? That sounds like a lot of work, right? I'm not actually going to do that. So what I am going to do, yeah, so that was what I wanted to show you, was creating a list like this by hand. Does not sound like fun, right? Every single port that your domain controller uses. Anybody know how many that is off the top of their head? It's 17, exactly. It's either 17 or 42, right? One of the two. But no, it's a lot, and it's way too much work to sit down and do it. So why don't I do something, create something that'll automatically parse the logs for me. So that's why I wrote Bropy, is to parse those logs. So my baseline report script will create the logs, and then Bropy will parse them and create that list for you. As far as generating the list, all it is a yes/no prompt. This connection was made. Do you want it in your baseline? Yes, you do. No, you don't. Pretty simple, right? So like, if you can't tell, I was in the Army, so I had to keep things simple so that I wouldn't not be able to do it. So as far as my scenario network goes, hopefully my onion will come back up. But I built this network with a couple hundred systems, a couple servers, SQL server, SharePoint server, WSUS, RDP, and a DC. And I was like, I'm going to baseline all of this stuff in an hour. That was the goal, was to be able to get a list of every single port and protocol that I was actually using in less than an hour. So that's what Bropy does. There we go. Well, except for not really. That's okay. I can work with this. That's tiny. So, Bropy, let's do this. So all I'm going to do to go ahead and install Bropy is just git clone it. I already have it, but pull it down off GitHub. You've got 3 files in there that you're actually going to use. So baseline.data, that's your baseline. That's what that is. Baseline report.bro, that's the script that generates all the alerts, and then Bropy is what does all the magic for us so that we don't have to do very much work. So I'm just going to sudo Bropy. Oh. Yeah. Oh, I'm already root. That's awesome. I'm not crazy, right? Oh, .py. Thank you. There we go. And we can't read it because I turned this too big. But basically, it pops you up with a menu. Would you rather be able to read it or make it look pretty? You can read it? Okay. Cool. So I've got 3 options. Really, I only have 2. So the first one, this is just for, I trust everything in the network. What it's going to do, it's going to automatically go out and build you a baseline based on your bro logs. We don't necessarily want to automatically trust everything that's already happened in our network, right? That's probably a bad thing to do. So I would generate this and then pass it out to my server admins and be like, hey, are all these ports actual ports? So now you have facts. These ports are being used. And you can say, sysadmin, this is your job. What are these? And if he can't answer you, then we probably don't need to let him happen, right? The second option that we have is to step through every single alert that was generated. And then the third is just to install it. So we do have to start with install. So I'm going to do 3. And we tell it what subnet do we want to watch. Like I said, you don't want to check every single packet. You just want to check the ones that are important, right? We're doing anomaly logging on this one small, very, very important piece of our network. If I want 5 sensors to do 5 different pieces, I can do that. But for this one instance, I want to do just these important ones. So I'm going to go ahead and do my server subnet from my lab, 156.22.11.0/24. And you can do multiple subnets, just do comma separated, and it becomes easy. If you want to do a particular host, just do a /32. It's going to do some checks and see, like, do you want to overwrite things that already exist? I'm going to go ahead and overwrite things that already exist. I'm going to overwrite my previous script, and then do I want to restart bro? So that line right there, do you want to restart bro, actually happened after I asked my buddy to demo the tool for me. I was like, hey, can you try this? I know you've got like 500 bro installs across your network. Can you run this for me? And he installed it, and then it automatically restarted every single sensor of his. So he has like an hour of downtime, and I feel really bad about it. But he probably should have done some code review before he just ran random stuff on his production network. So I blame me, but I also, a little bit, I blame him. But so now we have are you ready to restart bro? That's why that's there. All right, so I installed Bropy. Everything's already configured for me. All I have to do now is generate some traffic. So I've got honk baseline.pcap, and that's just my baseline traffic, right? It's just a recording of a week. So sudo so TCP. And I'm going to go ahead and use it to replay that traffic. So if I take a look, ls/nsm bro logs current, I don't have any logs there. Demo gods are awesome. Okay. I played all that stuff. So what I should see here, I'm just going to go ahead and roll on because this is going to be a bad day for me. So what I should see here, I've got my standard error and my reporter log, so I'm sure I just crashed bro instead of installing it appropriately. But what I should see here is a notice log. In that notice log, I'll have a bunch of alerts that say non-standard traffic detected. Whenever I run Bropy again, now that I've actually ran Bropy once, I can actually hit 1, and it'll go through, parse all of my logs, and generate a baseline file. So I'm going to hit yes to restart, but then I'm also going to go ahead and take a look at my my new baseline file. So that'll be less share bro. So I replayed that PCAP and ran Bropy. Now I have a list of every single port, protocol, and destination host that happened in that PCAP. So you see ICMP, the 128 box, got pinged a lot from a lot of hosts. So I can actually see that now visibly, right? And I didn't have to do any of this. It all just got created for me. Really, really nice. If I wanted to go in and maybe, SMB traffic, right? I know it's going to exist for my entire network. I'll see a bunch of these, 192, 168, whatevers. I'll probably change this /32 using vi to be a 24, whatever my network is. So you can go in and manually do that. In the future, it'd be great if I had like a bunch of people that know Python to come help me work on this and make it better. But that we could do that, right, at the command line. Say, do you want the default 32 or do you want to put in a custom subnet mask that's authorized? That would be great. It wouldn't be too hard to do, but I just haven't had the time to put it in there yet. Yes. So just to recap my awesomely failed demo, I'm sorry about that. You just git clone, change directory into it, and run Bropy, tell it to install. Once it's done, gather your traffic, you'll have logs. Run Bropy again, and either step through each individual log and say yes, no, or have it auto-generate and then manually take a look at the lists. Because now instead of having to parse through and do searches, you have a list. So just go through it, have your engineers do the work as to whether or not people should be connecting to those ports. And then, so use cases. These are the three things that I love. That's the reason why I wrote the tool. I now have a list of everything that's connecting to my critical resources. I can get alerts whenever new hosts connect to it or a new service pops up, right? I know we have that with like pads and stuff like that, but I wanted a lot of things in one spot for me, and that's why I did it. And then with our baseline data, so I get this baseline employed and I go a month without any logs. How about I just take that baseline, pass it off to my engineering team on the networking side, and say, this is the only traffic that's allowed to happen to go into our network. That's it. Just these. And then somebody is probably your CIO. He's going to be like, but is that going to break anything? Because the website has to stay up. And you're going to be like, I can guarantee you that nothing will be broken because I haven't had any alerts in a month and nobody's using any ports other than these. So you can guarantee your CIO, we are only using these ports if you have a list of all the ports that you use. So that's that. Any questions? Okay, in the back.
So whenever you hear about baselining and anomaly detection, you hear machine learning.
Right.
Did you ever look at machine learning as ideas around machine learning as a backup?
Yeah, so if you're really good at machine learning and those type of maths, you can totally come help me make this better. So that's the thing, right? Is and I say this all the time to my students. It's like I'm just a guy playing with Legos right now, and so I know a little bit of this and a little bit of this, and it'll solve my problem. It might not be the $50 Death Star Lego kit. Mine's actually a bunch of blue and green Legos, but I think it looks like the Death Star. So but yeah, I love the idea, and as soon as I can find somebody to help me with it, that would be amazing.
We're working on some machine learning aspects of using baseline detection, using classification and so on.
Okay.
But yeah, yours is definitely limited to like ports in particular. That's what we talked about.
Right.
Whereas we're looking at sort of the overall broader sense of traffic over the destination points.
Okay. Cool. Yeah, no, I would love to hear more about that. So, anybody else? Yeah, so it's creating new logs. Somebody brought it up the other day. We do a nerd night in Augusta every couple weeks. And somebody was like, well, but you're putting your own thing that makes these alerts, but how about you just read the bro logs that already exist? And so that's a definite feature that I'm going to try and get in soon because, yeah, initially just read all the old bro logs, and then now you can have the anomaly logging. Yeah, so that would have been way easier. So, anybody else? Okay,
I was just wondering, I don't work in development at all, but would it be hard to take this like a step deeper instead of, the source and destination, have these source destination work to move towards more application based?
Yes. So what end state, right? My initial baseline.data file had the name of the service, the hash of the binary that was actually hosting the service, like that kind of thing. And my goal was to have you run Bropy with creds, and it reaches out and contacts, does a netstat, pulls down the hash of the file, and then brings it back in. And it's like, okay, not only should those be the only things that are listening, but they should be hosted by this particular hash for this service, right? That would have been super cool, but yeah. Thank you for your question. Anybody else? I'm going to see if I can get this to work now that I snapshot it. No? Okay. Well, thank you for your time. If you want to stay and watch me try and fix this, you can. You're not going to hurt my feelings if you get up and throw stuff and walk away. All right.